Today we're going to look at percent yield. This is part of the Chapter 9 material, stoichiometry. The equation for percent yield is the actual yield that we get from an experiment divided by the theoretical yield. The theoretical yield is what we solve when we work a stoichiometry problem. So it is our stoichiometry result. So let's work an example right here. What is the percent yield if 24.8 grams of calcium carbonate produces 13.1 grams of calcium oxide? The first thing we're going to need to do is calculate a theoretical yield of calcium oxide. So we're interested in how much we produce. So our find in this case is grams of calcium oxide. We are looking for the theoretical yield. And our given is based on the amount of calcium carbonate that we are given, which is 24.8 grams of calcium carbonate. So let's go ahead and work this problem as a review on stoichiometry. We start with our 24.8 grams of calcium carbonate. And we're going to convert over to moles of calcium carbonate so that we can use the mole ratio to solve the problems. So we're going to bring grams of calcium carbonate down, convert it to moles of calcium carbonate. One mole of calcium carbonate is equal to 100.09 grams of calcium carbonate. We get this from the periodic table, the mass of calcium, carbon, and 3 oxygens. We are now out of the grams of calcium carbonate, and we are ready to move over to moles of calcium oxide so we can calculate grams of calcium oxide. So we're going to bring moles of calcium carbonate down. We're going to convert to moles of calcium oxide. We look back at our original problem, and it is a 1-to-1 ratio. So for every mole of calcium carbonate, we produce 1 mole of calcium oxide. We look again at our find, and we're trying to find grams. So we're going to cancel out the moles of calcium oxide and convert to grams of calcium oxide. We know for every mole of calcium oxide, we have to have 56.08 grams of calcium oxide, and this comes from the periodic table. If you plug this all into your calculator, you're going to get 13.895 grams of calcium oxide. Now, don't forget that you need to correct for significant figures. So this becomes 13.9 grams of calcium oxide based on the given here having 3 significant figures. That is step 1. We've now calculated the theoretical yield. Our next step is to calculate the percent yield. And remember that that is actual over theoretical And then we would multiply it by 100 to convert it to percent. So in this case, our actual, this is how much we actually made. So we have 13.1 grams. This is how much we should have made. This is the stoichiometric or theoretical yield. I'm going to divide that by 13.9, multiply by 100, and your answer for your percent yield is 94.2%. Put a box around it so I know that that is your final answer. Right, here's another problem down here for you to solve. I'll get you started. So we have 6.00 grams of aluminum oxide reacted with excess bromine to yield 50.3 grams of aluminum bromide. Let's just try another way of approaching this, and we're going to write the amounts up on top of the actual problem. So we started with 6.00 grams of this material, and we produced 50.3 grams of this material. This is our actual yield right here. This is our given. So your given is going to be 6.00 grams of aluminum. And your find, remember we're doing the stoichiometry problem first, is going to be the grams of aluminum bromide. Make sure you use aluminum bromide subscript 3 that we should have made if everything went well. I'm going to pause here. I want you to work the problem, and then I will show you the answer. Here is the answer for the theoretical yield worked out. We did the stoichiometry and found out we should have produced 59.3 grams of aluminum bromide. This is our theoretical yield. Then we came back to see how much we actually produced, which was the 50.3 grams. We plugged this into actual over theoretical, multiplied by 100 to convert it to percent, and got 84.8% yield. Turn the page, and we're going to work one more example. This is example 3. The photosynthesis reaction produced 270 grams of glucose from 180.2 grams of water and excess carbon dioxide. What was the percent yield? Well, let's identify first which one of these compounds is glucose. Glucose is the C6H12O6 compound. And let's label what we did here. The photosynthesis reaction produced 270 grams of glucose. So we made 270 grams of this material from 180.2 grams of water. So we have 180.2 grams of the water. What was the percent yield? This is on the product side, so this here is our actual yield. So let's go ahead and label that. There's our actual yield. So in this case, your given is 180.2 grams of water, and your find for the theoretical yield is going to be the grams of C6H12O6. Pause here, solve the problem, then check your answer. Here is the worked solution for the problem. We converted from grams of H2O to moles of water. Then we used the mole ratio of water to glucose to switch over to calculating the quantities for glucose, then to grams of glucose. So this was our theoretical yield here. So there's our theoretical. And then we used the equation, actual over theoretical, converted it to percent, and there's the final answer.